Hey gang, here we go. We are going to talk about systems of inequalities and graphing those. I'm going to give you a couple of examples, and these are actually taken from page 46, I believe, in your workbook. So you can finish page 46 from your workbook after we go through these two examples. All right. Let's see. Okay, so graphing inequalities is really a lot like graphing just an equality with an extra step. So one of the things we're going to want to consider when we're finished graphing is if we're taking a look at a less than or greater than situation, that kind of graph is always graphed with a dashed line. So I want you to keep that in mind as we're thinking about drawing our line. If we have a less than equal to or greater than equal to situation, we're going to think about not a dashed line this time, but a solid line. Okay, so the solid line indicates that every point on that line is actually a solution to your system, as well as the shaded areas that you'll see in our intersection. Okay, and the two problems that I've picked, we're going to tackle this in two different ways. One of the things we're going to do is we're going to kind of revisit how to graph a linear function that is given in standard form, and then also, of course, we'll graph and set things equal to y equals mx plus b, kind of change things to slope-intercept form. So we're going to tackle some of that graphing in that way. The other thing that we're going to take a look at and try and remember is that if we have x equals any number, okay, x equals a number, that is going to be graphed as a vertical line that passes through the x-axis at that number. And then in addition to that, we have this idea of, let's see, what should we use here? Something fun, light blue. Okay, so in addition, if we have a y equals a number, right? So just x equals or y equals a number is going to result in a horizontal line. Okay, so that's going to be horizontal, and it is going to pass through the y-axis at that number. So let's take a minute and let's just graph on this graph right here. Let's jump in and take a look at just this idea of x equals a number or y equals a number and how that looks. So right here we see x is greater than or equal to a -3. Okay, so I'm just going to start by graphing x is equal to a -3. So I'm going to go to -3 on the x-axis. I'm going to start making my vertical line. I'm going to ask myself, is this a greater than or is this a greater than equal to? I see that it's a greater than or equal to, so I'm going to draw a solid line just like that. Okay. And then to decide which side of my coordinate plane I'm going to be shading that also makes this statement true, you can pick a point, like 0, 0. That's always a good point to pick to kind of test. You can pick any other point. You can remember that we're looking for all values of x that are greater than or equal to -3. And that happens in this part of our graph, all through there. Okay, 0 was the point we were going to try. Is 0 greater than or equal to a -3? Because we said yes, we shaded on the side that included that 0. Okay. Let's try a y equals. In this problem, they've used -3 again, but this time they have just a strictly less than. So you're asking yourself again, is it strictly less than or is it less than or equal to? And because it is actually strictly less than, at -3, we're going to draw a dashed horizontal line through -3, just like that. And we want values that are less than -3. So if we try 0, 0 is actually not less than -3. So that means we actually want to shade on the other side of our coordinate plane from where 0 is being indicated. And of course, all of these numbers, -4, -5, and on down to -infinity, are less than -3. So it should make sense to shade below. Okay, so that's a little review on graphing horizontal and vertical lines, all right, and how that looks with an inequality. Now, let's take a minute and we're going to come back here to question number 5, and I'm going to switch up some colors here real quick. And we're going to try x minus 3y is less than a -9. Okay. And what I'm going to do is I'm going to first notice that this is a strictly less than, so whatever graph I am going to be drawing is going to be one of these kind of dashed lines that we saw here at the top, not solid. When an equation is in standard form, one of the things that we can do is we can find the x and the y intercept in order to graph. So if I plug a 0 in for x and I solve for y, dividing by a -3, I get y is less than, switch your inequality, because you've divided by a negative. Okay, so I have a point 0.03. I'm going to just mark it right there. That was when I plugged in a 0 for x. I got a 3 for my y. Okay, let's try plugging in a 0 for y. All right, kind of scroll this up just a smidge. So this time, if I plug a 0 in, I get x minus 0 is less than -3. So if I plug a 0 in for y, I end up with a -3 for x. So when an equation is in standard form, this is a really nice way, just plugging a 0 in for x or a 0 in for y to solve for intercepts. Let's look at these points and graph our line. So 0, 3, 0, 1, 2, 3. Okay, and -3, 0, so -3, 0 is right here. I knew I was going to have a dashed line, so my line is going to look something like that, and I'm going to test the point 0, 0 to see which side of this line I should shade. So let's try it. 0 minus 3 times 0. I want to see if it's actually less than a -9. So this gives me 0 is less than a -9. Is 0 less than a -9? I don't think so. So that means I'm going to shade above this line. You guys might remember this from algebra, and that our solution is this intersecting piece right here. This spot that is intersecting both purple and red actually is the solution for our system. So that's the region where points actually fulfill both systems, or both equations, which makes it a system. Okay, so that's how we did that one. Let's come back here and finish this last one here. And we're going to finish up with 2x plus y less than or equal to 1. And I'm going to go ahead and change this to the form y equals mx plus b in order to graph. So I'm going to subtract 2x from both sides. Minus 2x, I get y is less than or equal to a -2x plus 1. That means my slope is a -2 over 1. My y-intercept is 1. And then I'm going to test a point. Notice that this is less than and equal to, so I'm going to make sure that when I graph my line that it is a solid line. Okay, slope is negative, so I'm going to go down to over 1. I'm going to make this line the best that I can here. It's going to be a solid line passing through 1 with a slope of -2. And see that little point 0, 0? I'm going to test that point. It's not on the line. It's actually kind of below the line right there. Let's test it. So here's the test. I'm going to go ahead and throw it in there for 2 times 0 plus 0 is less than or equal to 1. So that means that I'm trying to see if 0 is less than or equal to 1. And it is, in fact. So that means I'm shading on the side that includes that point 0, 0. So I'm shading below my solid line. And I'm looking for that part that is the intersection. And if I highlight it again, kind of like I highlighted my other intersecting region, you can see that this area, now that I'm kind of highlighting in pink, that has both the green and the blue highlighting. So that is my intersecting shaded region. All right, nice little overview for you guys on solving systems of equations. Hopefully that was super helpful and that you can do a few on your own now. You guys have some work to do for me this week. Stay after it. We're almost to fall break, guys. Good job.